Thanks everyone for having me. So today I'm going to talk a little bit about my view on sort of the research sector and the activities across that space, and then talk about the Eratos platform. And hopefully it'll be quite clear as to why I'm actually quite passionate about this company and the tools that they can offer. And hopefully that is something that you just enjoy the presentation, if nothing else. So I've been working on this particular slide now for almost a decade. It's had a lot of input from a lot of people, but it's really I think it captures a lot of the sort of elements of what we have to deal with in the research sector. So along the y-axis here, we have the impact of research and and basically my view is research needs to be used in some way in order for it to be useful. So there's lots of fundamental research that we know has had a lot of impact, but it's only because it's being used. And so it has to go across this spectrum from being fundamental research through to some kind of utility and through the applied space, then get into a development context of where it actually starts being implemented in a prototype of some kind, and then gets operationalized out into the green space there. And that's where extension officers need to spend a lot of time teaching people about the solutions that currently exist. Now, on the y-axis, we've got resources. So could be any kind of inputs, dollars, time, but basically research costs money. It doesn't generate income, and it doesn't save time. What research does is it costs both of those things. But then what we hope is that the outputs from research get operationalized into the day-to-day operations. It could be of a research organization, but it gets operationalized, and that's where all the savings come. That's where we can do things cheaper, we can do things faster, we can do things at higher quality, those types of outputs. And so this is a sort of general kind of context. Now, across this spectrum, I've labeled a number of little points there, 1, 2, 3, 4, 5, 6, 7. And this is to try and identify where some of the key barriers are. So inside the fundamental research space, the biggest barrier is actually domain expertise. It takes a lot of training and a lot of effort to be able to do fundamental research in almost any space, but some spaces you need less to get started. But the idea is that you need to have a really, really strong understanding of a particular space in order to make any real meaningful progress. Some fundamental research is very expensive. I come from a background of Antarctic research, and to get the ship down to Antarctica costs $200,000 a day. It's a very expensive exercise being down there. So there are similar kind of very expensive areas of research, and that's why that big blue wedge goes up to very, very high costs. It also could be that you're doing this type of research, ice coring, for example, collecting ice cores out of glaciers or out of Antarctica, and you go and collect those ice cores. We've been collecting ice cores as a kind of species for more than 100 years. And we didn't really figure out how we could use them in any meaningful way up until the last sort of 30 years, outside of sort of general kind of knowledge. And so I think, and even converting it into knowledge takes a lot of time. And I'd say a textbook sits in the green zone, for example. So we've got that fundamental research zone. Then you've got the applied research zone, which is where you take knowledge and you start trying to apply it in a really useful way. Agricultural science is a really nice space of this. We now understand that there are bacteria that live in the soil. How can we use that in a sensible way in agriculture? Let's do things. Can we change the productivity of agriculture by increasing the amount of good bacteria in soil? That kind of, having those transfers of knowledge. And there's a real barrier, which is number 2, of the fundamental researchers having a strong enough understanding of the applied space to be able to take that fundamental knowledge and start applying it. And that's a real skill set to actually have enough understanding on both sides of that. And that's why there's a knowledge transfer barrier there. And it's really about purpose and drivers. So people who are doing fundamental research are really trying to understand the mechanics of a system, Whereas in applied research, they're really trying to understand, how can I use this information? I want to do something useful with it. And that's a really fundamental different mindset and it means that actually it's a barrier to collaboration across that boundary sometimes because the people are there. Then we go over to the yellow zone where we're in development. This is where you've got technical experts operating in government or maybe inside commercial organizations. And then you've got policy experts, again, people writing policy in government, or maybe writing policies of, the HR policy inside a big multinational, for example. So it's about, but the technical experts and the policy experts are actually separate little groups. They often operate quite separately to each other in different parts of the business. The technical experts are usually quite good at picking up applied research and figuring out how to use it inside the business. But and that's where you need that barrier there to overcome is expertise, having expertise in the business or in the government department, understanding the right methods and understanding the right tools. But the technical experts aren't the ones who implement change across an organization. It's actually the policy experts. They're the ones that are the directors, the executive level managers that do that. And so understanding the operational requirements of a government department, or how do you take this research and actually make it useful in an operational sense, is an internal barrier inside those organizations. And you'll notice I've put the word commercialization there as well. So how do you actually take something and make it work? And you've got those policy requirements. IP ownership mismanagement often happens in that space there. That's when people get involved and get a lawyer in, and you haven't even built a solution yet, but there's talking about who owns the IP. Getting it from that development stage out into the real world, that takes a lot of political will and community acceptance. It's a social thing. How do you get people to accept that they need to take on a new solution in whatever space that is? It could be you've written a new policy and you need to roll that out and you need to get it past the minister, or it could be that you've created a new software tool and people can get lots of benefits from it, but you need to convince them to give it a crack. And you'll see that they've got the innovators, the early adopters, the early majority and the late majority kind of across that space to give a sense of how that works. And then finally, you've got that commercial research culture clash. When you are actually trying to roll out into the operational space, there's actually a fundamental difference on the way people that work in building solutions and designing up new products, how they think and how they work, and how researchers are solving the problem. And there's a mismatch there. So then if we talk about this as being enablers and overcoming each of these barriers. So I've put forward the problems. How about we talk about some of the solutions? So in area one, it's about having cross and transdisciplinary teams, building up teams that have lots of the fundamental knowledge, and then allowing them to talk to each other so that they can share their solutions across those teams. When you're going from fundamental research to applied research, it's really going from problem and solution oriented, going from mechanistic understanding of systems to problem and solution oriented project design. So we have a very clear outcome that we're trying to develop. So how do we make sure that the proposals and everything is structured in a way that delivers towards that final end goal? Inside the applied research space, we need really good research community managers and curators, not dissimilar to the DARE community that you've got here, where people can actually help tell people these are the best tools to use right now. These are the people that you should be talking to in order for that to best work. So taking people through these, providing that curation space, providing that community management overcomes that barrier of finding the right expertise or finding the right tools or methods to apply. At barrier number 4, which is the barrier between the applied research and then actually going into proper development of solutions, we have that operational staff need to be embedded in research teams. When you have technical experts from particular organizations, be it a government department or a commercial organization, who are working on the research solution, they know what their day-to-day job needs to look like, and they know what the applied solution needs to look like for them to be able to use it. And so they actually influence design throughout the research project. Then we go to number 5. We need policy-led technical communities of practice. We need those policy experts to actually be the ones going in and supporting their technical teams to work inside those organizations to deliver what those policy experts are after, those broader scale organizational outcomes. How do we save money? How do we deliver things faster? How do we increase the quality of what we're doing? There needs to be that internal recognition of work that needs to be done inside the user base. At number 6, we then go, this is a cost management and user testing exercise. So once you've built a solution, you then need to go into sort of that proper optimization. Can you deliver whatever it is that you've built in a way that is cost effective, that means that there's a strong return on investment, that the people that you're testing it with go, this is helping me in some way, shape, or form. So that's a really important step to do. And once you've got through that step, then you start going, right, how do we increase our client base? How do we make sure we have a really large user group? How do we make sure that there's the right kind of revenue sharing arrangements? We needed this big stack of people. We needed service, we needed marketers, we needed people who were on the support desk. We needed all these things. There's a big stack of services. How do we make sure that they're all getting paid for that work at the other end, at that operationalization of this research? And then you have IP management, and you'll notice that I've put it all the way out there. Once you've actually proven that you've got something and it's valuable and it's actually helping people, that's when to talk, and you understand how much it costs to deliver. That's when you can start talking about, like, so who actually deserves to have the IP based on where this has got to at the end of this process. And this is Tom's view on the world and of the research sector. And I find that this really helps to frame up some of the other stuff that comes through, and certainly why I've have been really excited to be working with Eratos for the last few years, helping to try and build a platform that accelerates movement across this spectrum. When you get 1 to 7 right, you can go from fundamental research all the way through to an operationalized product incredibly quickly. In the right, like COVID is a fantastic example of this. What is the virus, and what is causing this sickness? How do we fix that? What are the vaccines we need? That's fundamental research. Then you go into applied research. How do we deliver that to humans? How do we make sure that we have the cooling systems in place that we need to keep the vaccines at the right temperature when we're rolling it out globally? How do we have the right people in place to deliver those vaccines out and the like, and have all the policies in place that means that we're allowed to, and then roll that, and who's going to do all of the work of delivering it, like the nurses and the pharmacists that were able to do it at the end. That happened in an incredibly short period of time. And so it is possible to do this. Humans can do it, but we need to really work on building those systems that allow us to do this more often and in different sectors. So coming in more about sort of what's Eratos about and what do we need with research? With research, we need good curation of data sets. We need good curation of toolkits. We need good curation of communities. And Eratos tries to help solve that problem. We need to provide spaces where researchers can collaborate more together and bring in people from across different organizations. I've often been in projects where I've had CSIRO, the Bureau, 4 universities, and then some private enterprise all trying to work together. It's really difficult to find computational environments that allow all those people in a really simple and straightforward way. And that's one of the things we've tried to build, and I hope to demo a bit later on. And then the last bit is we need to have mechanisms that allow us to take the prototypes that we've developed in that applied research space and try applying that out into sort of operationalized spaces, provide business models that allow us to say, is this the type of business model that fits this solution? And provide the platform that allows those ideas to be, particularly in the technology space, to be rolled out in ways that can really help impact society. Okay, so what Eratos is trying to build is data insights at a planetary scale. Eratos is a data and AI platform and it's there for individuals to use as well as teams and organizations. And it's really, there's two parts, but it's set up to organize, find, and access data, provide mechanisms to transform data, particularly, and have your public, the vast public data sets that are available sitting alongside private data sets that are just need to be seen by an internal team. And then be able to create these novel insights at scale and also deliver that out to the community. If you can imagine dropping a pin anywhere on the planet and being able to say, let me know about all the data that happens to be associated with that location, and be able to then go through your own curation step of like what you need to solve your problem. That's what Eratos is trying to build. And it already has built the infrastructure. We're now just building out the catalog. We do this through three fundamental steps or three fundamental components of the platform. We access, which is federated access to data. This is in a common data environment. It's basically a big catalog that just says, we know where the data is, we know how it's stored, and we know how you can get, and we know how you can get access to it. We then have a build and collaborate component, which allows multiple people to log into the same space, be that a Jupyter environment or an RStudio environment, and actually work in the cloud and develop there. So you can get people off their laptops, and you can also start deploying the computational environments ready to go so that they don't have to set up their Python environment so that a particular package will work. That's all ready to go out of the box, and that can be set up for particular research teams. And this is done in a scalable way that also is in a commercially available environment. I used to use Nectar a lot. I love Nectar for those that are aware of it. But I wasn't allowed to use Nectar for consulting work. And so I needed a space to go after that. And that's what Eratos is helping to try and solve. And then finally, a marketplace. I've built a whole bunch of really cool products, but I didn't have anywhere to put them. It was really hard to find a place, a group that was willing to take them. And Eratos has a marketplace where you can control delivery out to whoever you like in the ecosystem. So Eratos is all about trying to create a frictionless environment for collaboration and a frictionless environment for getting access to data. Without Eratos, you end up in this picture on the left where every organization needs to have a relationship with every other organization in the system. This is really inefficient. It makes it really hard to find information, really hard to set up licensing agreements and contracting agreements. And it's really hard to understand who's still in the network and what you can actually still do. With Eratos, all of that is everyone comes to an Eratos platform and all of that is handled. IP rights and sharing is all well agreed. Standardized license agreements that everyone can just say, tick. Think about logging into the Apple marketplace and buying something. You don't have to worry about the licensing agreements. You just have to say agree. So it's about having those types of things set up so it's all standard. It massively lowers the cost of operationalizing research and particularly of managing teams. And revenue that's of anything deployed in the marketplace is owned by the creators of that IP. And so this is a real space that I think allows particularly university researchers to start leveraging how they can start selling things through the platform that are worthwhile selling, or alternatively, just making things available in a supported way and in an easier to find way so you can have more impact. So we think about the whole sort of stack of services as a bunch of Lego bricks. So you've got the core, which is the development environment. And then after that, you've got the workflow orchestration with Synapse. And then also the data spaces where you have the cloud developer environment that allows you to build workflows or to have more of a sandbox to play in. And I'll talk a bit about that later. And then the marketplace. So for this particular project, which is Pharma, which we're working on with CSIRO and has been funded by GRDC, it's the frost and heat mitigation analytics platform. Here we've got the data on one side, which for this particular project, we had Bureau of Meteorology data and Himalaya satellite data. And we also had sensors deployed in the field. And so Eratos helped integrate those data sets together. And as it happens, when you sign up to using Eratos, you also get access to the Bureau forecast data sets for free as well. So So that what that is integrating those data sets so that a researcher can come in and actually build the downstream algorithms they need with all those inputs seamlessly. So in this particular example, there were two models that were developed from different parts of CSIRO who actually had nothing to do with each other. There's the SNAP 30-meter frost model and also the Mars model. The Mars model takes the observational data, fills in all of the gaps of what's happened, takes out the cloud, and then the SNAP model estimates the frost based on elevation and a bunch of other things and downscales that to very high resolution. So this is where you have the models sitting on top of the data. And then you get to the value, which is the overnight frost analysis. This is important for grains industry because they have huge areas that they manage. And it can often take a long time to go out and check if a particular paddock has actually had bad frost overnight. So being able to look at a product that saves you a whole bunch of travel time is really valuable to them. But then also it's valuable to the insurance sector. It's valuable to people trying to estimate how much grain is going to be having to go on ships for the logistics. There are lots of people that are interested in that last step. The whole stack, the blue and the green stuff has to happen, but it's that last step where the value lies. In this particular project, it's a collaboration of government, industry, and research. And by setting up the project with dedicated spaces, they were able to share this through data, tools, software development through the platform without having to worry about their institutional silos and firewalls and the like. We were able to get solutions around that. So this is a bit more of a workflow of how this works. We start off with the calibrated satellite data that comes out of places like NOAA and JASA. Those raw bands come in, and we had to build the Eratos e-Himawari data product. This is a product that was analysis ready for the other two products that I mentioned, the cloud masking and the land surface temperature. Then we combine those two other models together, and you end up with the CSIRO cloud masked LST model, land surface temperature model, at 2 kilometre resolution. This then is an input to CSIRO's SNAP model, which does the frost area, and then we end up with the frost maps. That then gets delivered out to the end users who are farmers, agronomists, or maybe agricultural tech companies. This project is still live and it's still being commercialised. This project is still being commercialised, but something that came out of this is because of the way that within the Eratos platform everything is very modular. Something popped out, and some other actually were giving a presentation of the great work they were doing to get to the purple box. A research organisation said, "Hey, could we have the cloud masked LST at 2 kilometres?" And so because of the modular component of how this was built, it was able to start being a completely different service that no one was expecting. And as you will all be aware, there's lots of this type of stuff that happens through research. You have to build a whole bunch of things to get to the final value step, but all of those other bits are really valuable, and the more we can share those components, the faster we can solve problems across the entire ecosystem. This is further enhanced because one of the projects we're working on is about calibration of satellite data. And calibration of satellite data is a whole nother workflow in itself, but it actually shows how you can build on top of the existing systems that have been built in the Eratos very easily to start enhancing the products. And that's exactly what's happening here, where the calibrated satellite data is going to be further enhanced by some other calibration and validation activity that is happening through CSIRO as well. And they were able to link these two projects together seamlessly because of the way the modular component of how the platform works. There are lots of other platforms lots of other projects that Eratos is working on. One of which that I was involved with when I was with the University of Tasmania was the Federated Climate Data Initiative, bringing together high resolution climate projections across the country. And that's been incredibly successful at speeding up access to data. There are lots of projects we're working on. And this is more to just give a sense of the variety of things that you can do with the platform. Some is using real-time sensor data, some is using historical data sets, some is using satellite data. It's very, very much about using sort of existing data feeds and then putting them into operational workflows that people can then use to make real decisions. So one of the things I've been involved with in the last few months is really helping to guide and develop up the thing we call the Eratos sidecar. Now, when I first spoke to Willem and the team over in West Australia, we didn't have this product, so it's hot off the press. But I'd love to show you what it does and how we can how it might be useful. Inside the the Eratos workplace home, there's the Eratos sidecar, and what a sidecar is a cloud developer environment connected to the common data environment. So if you click on this, it launches a new card that then you can say, I want to install this and get it running. This is free to get started. I might as well click on that and show you. So here you can set up a new demo and then click on this and get started. And it will launch a VM in the cloud with RStudio running, ready for you to go. I've got one pre-prepared. It takes about 2 minutes to launch, but I've got one pre-prepared here just for demonstration purposes. One thing I will show you though is once you click on that, it then opens a dedicated space. You can invite other people to join this space if you want. And inside here, it just has my login details on how to get into this particular cloud environment. And I just put that in a normal RStudio space. What I can do is I'll show you exactly that because it's all RStudio. So you can say launch, it then launches. So then you have an RStudio environment. Here, straight out of the box, you have some examples and that just show how things work. And that's what I just wanted to run through here. In this environment, for example, this one here is to say, let's get the weather forecast. When I was at the eResearch conference, we set this up for Brisbane. I haven't changed it for anywhere else right now. We want to have a look at the forecast data out of the Bureau of Meteorology's. So this is quite small. Let's see if I can make it a bit easier for you all to read. The Bureau of Meteorology's automated data forecast database. It has 3-hourly mean precipitation forecasts at 6 kilometre resolution. This is stored in a whole bunch of different data files in the background. And Eratos knows what that looks like in the catalogue and allows us to easily get access to it. And this comes out of the box if you have an Eratos account. Here you just have to, Eratos has to authenticate who I am. And so we do that using that tool there. And I'm just going to make that smaller again so we can look at what the outputs of that are. And so here it's just pulled the forecast data for the last year. It shows how that changes at daily time steps. And you can then use that in any subsequent downstream data flow. And it just shows how simple it is to access a particular data catalog component. There's a lot of APIs and a standard developer kit, an SDK to access. It's actually all based in Python, but there's also, we use I love using R, so I said you have to give me an R option to allow people to get access to this data. Once you create that data object, you can then use the SDK to ask for that data to be pulled down. The cool part about this is just looking at the catalog. It doesn't pull any data until you ask it to. And so it's incredibly fast to work with. You can build up a lot of stuff and make sure that you're looking at the right data, looking at all the metadata that you need very quickly. Here's just some things that we're setting that up. And then we just basically create the plots. Now, in a similar way, I'm not sure how many of you are also using, say, silo data. I'm just using examples because I'm a climate scientist that are in the climate science space. Here is another example of using the data, using it here, and here it's using Silo, which is from the Queensland government. Silo data set's fantastic for research. It was set up for agricultural research particularly. Silo data sets are stored as monthly files all the way back to 1900. And the Eratos catalog knows how they're stored and therefore knows how you can use the SDK and the APIs to query that in a really efficient way. But as you can see here, the user doesn't need to know very much about that data set in order to get started. They need the Eratos reference number. that will reference name that is explicit to every data set in the system. And then they can go through some pretty simple and standard approaches to accessing data to extract out exactly what's required for that particular query. Here is where the data actually gets extracted here. It takes some very simple inputs. And you'll notice that the inputs are the same for both the bureau data and for the silo data, even though they're completely different data sets stored in completely different ways. And so it simplifies the interface of accessing complex data archives for the end user. And if we run this particular one here, we are in the wrong one. Here we go. As long as I learn how to drive properly. And here, so that is that's the mean forecast from the Bureau weather data. And this one is the historical climate data for Brisbane location. There's also some cool stuff you can do here, but this is some work from Mike Sumner that who's from the Australian Antarctic Division. He's built some cloud native, cloud optimized geotiffs. And so he built up a little sort of example that goes off and hits the cloud optimized geotiffs that he's built and plots them in the system. This is installing new packages into the system that he needed to make the system work. So that's what that's doing. Just let that kind of kick along in the background. But that's it from me in terms of the examples and sort of an example of the platform. But I'll stop sharing while we're here. And if I'm happy to take any questions.